Hello, everyone, and welcome to another Jakarta Tech Talk. Joining us today, we have Santiago Perikas-Gersten to discuss the Jakarta REST update. Santiago is a principal member of the technical staff in the Sun Glassfish organization at Oracle, as well as an architect and technical lead in the Avatar project at Oracle. If you have any questions for Santiago as we move through today's presentation, feel free to ask it in the chat or using the Ask a Questions tab at the bottom. So without any further delay, Santiago, over to you.
Okay, so good afternoon and good morning, wherever you are. So today I'm going to give you an update on Jakarta REST. Jakarta REST is what we used to call Jakarta REST. So I'm sure in the presentation I'll be using the two terms interchangeably. I have to say that originally we had an abstract for this presentation which was more focused on the 4.0 version. But since that abstract, we have made some decisions about another version of Jakarta REST, which is 3.1. So I decided to include an update of 3.1 as well, as is the one that is going to become available soon. So for the agenda for today, then it's going to have an initial update on what we have in 3.1, and this is the release that is going to be proposed and has already been proposed for Jakarta EE10. And this is going to be a fully backward compatible release with all the other releases we have had of Jakarta REST or Jakarta REST. And then in the second part of the presentation, I'll talk a little bit about what's coming in the future, which is what we call Jakarta REST 4. And this is going to be a backward incompatible release. And that's the reason why it's been delayed a little bit as well. And we'll talk a little bit about why the incompatibility and what we're trying to accomplish in 4.0. So let's start with 3.1, and this is the one that you're going to be able to use if you're interested in Jakarta EE10. So 3.1 has been in the works for a long time, and the reason for the delay is all this migration that we had from the JCP to the Eclipse Foundation. We've worked on a lot of little and some of them not so little clarifications and fixes all across the board, trying to gather feedback from both Jakarta REST implementers as well as users. So here I include a list of some of the PRs that have been merged in the last year or 2 years in relation to this new release. And I'll also talk about two sort of larger features or major features that are going to be included in 3.1, and those are a new Bootstrap API for SE, for Java SE, as well as support for Multipart form data. So talking about the smaller clarifications first. If you're interested, you can use those numbers and go check out the PRs. I'll include a link to the GitHub location at the end of the presentation. But just briefly going over them, we've added auto-closable in a few more places where it made sense. The client is an important one where, especially if you're using clients on a server-side environment, you want to make sure that you close those and you free all the resources that they take, which can be significant. There have been a number of improvements around the SSE API, a lot of clarifications of things like, what happens when an error is reported with this particular event and how we're supposed to react to problems like that. And as you can see, we have had a few of those. We have a new extension loading mechanism for providers. Providers is something that you would use with your application. Examples of providers are message body readers and filters and things like that. And we never had a mechanism to load these dynamically. You always had to specify them programmatically or via some meta provider like a feature or things like that. It has been requested for a while the ability to use the service loading mechanism in Java to load these providers, and now this is going to be available finally. We have deprecated some things as well in preparation for release 4.0. One of them is get singletons. One of the things that you need to do when you write your Jakarta REST application, you typically have to create what we call the application subclass. And within it, you can override a method called get singletons. This is something that made sense way back when Jakarta REST was designed. It's not something that is very useful these days, especially when you consider integration with CDI and other things. So we're going to be deprecating this now and eliminating it later on. There have been some clarifications around matching rules, especially when you have requests that don't have all the headers that we expect during matching, things like content type, for example, and things of that nature. JAX-RS has had a static dependency on JAX-B for a long time, and this was a bit unfortunate, but it was introduced as part of two small classes that we have, and we want to eliminate that compile time dependency. So we're deprecating a couple of those, as you know, most of you use JSON these days and not so much XML. So you're still going to be able to use JAX-B, but there won't be any more dependency or static dependency, I should say. Web application exception is now serializable, something that probably should have been for a long time. Some improvements to the cookie class, as well as a default exception mapper. So if you're interested in any of these improvements, please go to GitHub and take a look. Today, what I'll talk more about is the new features that we have, primarily the Bootstrap API and the support for Multipart. Another thing that I have on the slide is the TCK separation. This is not something that will impact you unless you are a Jakarta REST implementer. But we are undergoing a lot of work to separate the TCK from the main repository into the Jakarta REST repository. We have, I believe, around 2,700 TCK tests. Not all of them can be migrated, but most of them will be migrated over time. Release 3.1 will have a subset, a pretty small subset of those, but we'll continue working on that for the next release. All right, so let's talk a little bit about the new features in 3.1. So the first one is the Bootstrap API. So up to this point, there was no way to write a Jakarta REST application that was fully portable unless you were working in some sort of application server or HTTP server or servlet environment or even microprofile. The main of your application was under control of something else, somebody else. But the use case for having a sort of completely standalone Jakarta REST application is something that grew in the last few years, and people have been asking for the ability to write a complete application, including the main for Jakarta REST. Now, with the advent of microprofile, this is a little bit less interesting than what it was at the time we started talking about it, but it's still useful for those that want to have an absolute minimal application and don't want to use anything else other than Jakarta REST. Some implementations provided this support, but it was not portable. So the idea here is to have something that is portable across implementations. And of course, this is going to require the implementation to embed an HTTP server in order to provide this feature. And the basic idea of the feature is that you have an application, you have some configuration, which is all API based, as we're going to see in a moment, and you just want to start an HTTP server using your application and don't have to use any external library for that purpose. Let's have a look at an example. So the application is what you defined before. Usually you would override some methods in that application and return the classes and the providers that you want to use. And all you really want to do once you have a Jakarta REST application is you want to start an instance, an HTTP server, and let those resources become available for clients to access. So the Bootstrap API, it's a very simple API. I should say that it's still undergoing some changes. There's a couple of PRs that are in the works to make it a little bit easier to use. But in essence, it's a reactive API. So you start and you get an event or information about the instance once the instance is up and running. And the idea there is that you could start up other things concurrently without having to wait and sort of hog the main thread here. Once it starts, you can get access to things like the port where it's running, assuming it's a dynamic port. You can get information. You can register things to when the VM shuts down so that you can properly clean up things and things of that nature. And so the only thing that in this slide that we are not talking about is configuration. We're assuming default configuration, so only the application is being provided. If you do need some configuration, then it's easy enough to do that. I should say that this configuration is only programmatic configuration. There is no external source for configuration defined in Jakarta REST. We wanted to keep things simple. But of course, there will be options for that in implementations, or even if you use an external libraries such as microprofile config. And so in this example, we put together a configuration to enable HTTPS or TLS, and we set up some sort of SSL context as is typically required for this operation. And once we have that configuration, we can go ahead and start the application, or the instance rather, in the same way we did before. So SE Bootstrap API, that's the shortest introduction I can give to it. The next feature we have is something that probably should have been there a long time ago, but for one reason or the other, never made it in. Many Jakarta REST implementations do support this, but once again, you do not have portability across implementations unless it's defined by the spec. So essentially what we're talking about here is support for the multipart form data type or media type. And the difference here is that you can have multiple entities, or what we call parts, and each one has its own set of headers and potentially a different media type, different content, and some additional metadata for that part. And so the way you would produce a multipart, of course, we support producing and consuming these. The way you would produce a multipart is simply using a list of entity parts. So entity part is one of the new types in the API. And we'll see an example of that in a moment. And the way you consume a multipart is either using a list, again, or using binding. You can bind specific parts to parameters in your resource method. And you can do that using add form param. So the way you do that is by specifying the name of the multipart as part of the annotation. And then you let the implementation just do the work for you. So let's take a couple. Let's look at a couple of slides about that. So then the first one is about producing a multipart. We have some sort of get method or resource method where we receive a query parameter that corresponds to a directory. So what we do is we open the directory, we go through the files, and we want to return a multipart form data that has the content of all those files. And for the sake of the example, we assume these are all PDF files. And so the new code here that is specific to JAX-RS is the fact that you can return a list of entity parts to begin with, and also you have a Fluent API to create one of these parts. And you can specify all the metadata for it, such as the name, the file name, which are different, the content and the media type, and so on and so forth. So very simple. You can produce multipart form data entities now. Now for the consumption part, as I said, you have an option to either using a list, which would be useful especially if you want to process all of them. But maybe you're interested in only some of them, and you can also bind them to specific Java types. So you can use the add form param annotation to do that, and there's only a few types that are supported, but you can extend the set of types that you can support that using message body readers, as you normally do. And but in this example, we have string, input stream, and entity part. You would bind it to an entity part if you're interested in getting the headers. If you do not bind it to an entity part, then the headers are not going to be accessible to you. If that's important, that's what you need to do. This is similar to when we use response in a normal request, in a normal resource. But other than that, it's all very Jakarta REST and fits in the rest of the API very nicely, the way you can process these. Okay, so these are the two new features, more important features, and again, this should have been there for a long time ago, but they finally made it in. So that was a quick update on REST 3.1, and so now I'd like to talk about what was the original motivation for this tech talk, which is a preview of what's coming later. And so almost all the preview is going to be about one decision that we're making going forward, which is the reason why it becomes backward incompatible. So let's talk about that a little bit. The decision has been made that there's really no point for Jakarta REST to provide its own minimalist dependency injection mechanism anymore. Those that have used Jakarta REST for a while are probably familiar with the add context annotation. And this is the way you inject things that are specific to Jakarta REST, that are provided by Jakarta REST. Interestingly, CDI and Jakarta REST, or JAX REST as it was called back then, sort of started around the same time. There have been integrations between the two, but JAX REST never had a static dependency on CDI. So you could use JAX REST in an environment where CDI was not available. But it turns out that over the years, CDI has become much more popular, and there's new work around CDI Lite that we'll talk about later in the presentation. And so it makes a lot more sense to just eliminate the things that were originally added to Jakarta REST and leverage CDI whenever we can. And this is the reason for the incompatibility. We obviously need to drop some of the ways we're doing things, as well as some of the annotations that we were using for injection. So we're going to drop support for add context. You're going to be using add inject in most of the places, and we'll talk a little bit more about that. Jakarta REST, or JAX REST, back then defined some scopes in the spec rather loosely. We defined the so-called per request scope or per application scope. And of course, these map really nicely to scopes that exist in CDI and are well known to all the programmers, which are request scope and application scope. So we'll definitely take advantage of those. One of the things we never quite had in Jakarta REST that it's another motivation to rely more on CDI is the discovery part. So you could do some discovery in a servlet environment using the servlet extension mechanism. Some of you may have used that before, but of course that doesn't necessarily apply to microservices, which may or may not be using servlets anymore. So the idea of discovery is very useful because sometimes you don't want to specify an application subclass. You just want your resources and providers to be automatically discovered. And this is something we can do with CDI. CDI supports portable extensions, and with portable extensions, you can do all sorts of things dynamically. And we'll talk a little bit more about that as well. So as I said, we want to drop all the compile time dependency with JAX-V. We're deprecating it in 3.1 and essentially dropping it in 4. I don't think a lot of people are actually using those classes. There's always people that use classes, of course, but I don't think they're terribly popular. The other thing we want to do going forward is review integration with other specs. One of the ones that comes to mind is Jakarta concurrency. Some of you may have heard about this one. Jakarta REST supports asynchronous processing, or asynchronous resources, I should say. And the integration with concurrency, of course, would make a lot of sense. And we want to propose all this for 11, which hopefully will be available sometime next year. All right, so let me just make sure that I didn't skip anything. Yeah. So removal of add context, what does that mean, and what is the implication of that for developers? Well, it's not huge, but there are some differences. Add inject can be used as add context in many places, but there's a few places where we need to be careful. Add inject cannot be used, at least not as of today, in a parameter precision, which is something that we use add context for all the time. Another thing that we need to keep in mind is some additional things that were added to JAX REST that work around add context, and one of those is context resolvers. These look a lot like CDI producers. In fact, they are far less powerful than CDI producers. So this is something that it doesn't make sense to keep around. There's some exceptions to that. We can use add producers with context resolvers to filter on media types. So we'll have to find an alternative there, probably using qualifiers or something like that. In general, constructor field property injection, we can all do it in the same way we do CDI. There are some differences when it comes to constructors and some restrictions that we need to be aware of. But for the most part, everything should work as before. The one question is what happens to the parameters that we inject in our resource methods? Well, the answer to that is that initially they will still be controlled by Jakarta REST because Jakarta REST is responsible for calling those methods. So typically you don't have injection in parameters in CDI for the most part because CDI doesn't call your business methods, at least not normally. But in the case of Jakarta REST, this is something we need to do, and we'll have full control over that, and I'll show you some examples of how that would work. There's some discussions in the CDI group about executable methods, which would be one way of implementing resource method invocations. If that becomes available, then we'll have to take a look at that and see if that's useful to us. Now, it could be that this is just an implementation thing, or it could actually have some implications on the API. So that's to be determined. All right, so here's an example of how things would look like, and for the most part, they are going to be very similar, and you'd be very familiar with them, but there are some minor differences. So on the left-hand side, we have a sampler resource class in 3.1. On the right-hand side, it would be 4.0. So first of all, we still use the same annotations that you're familiar with, such as add path. And we just want to make these annotations. We'll probably need to tweak these annotations a bit, and I'll talk about that later. The default scope in 3.1 is per request, so that maps rather nicely to request scope for the most part. And so in this example, we're being explicit. Maybe we'll decide that add request scope should be automatically added by the implementation, so you don't have to worry about the default scope. But just to be explicit, we're going to put it in here for this example. Things like URI info and things that you would normally inject using add context, you would just inject using add inject. Things that require qualifiers, such as a header parameter that takes a specific name, would probably require 2 annotations unless we do something about it. And you can see the injection on the right-hand side has an add inject and an add header parameter. One of the things that are definitely going to be different is the way we do constructors. So constructors have been a bit of a problem in this world where we had multiple dependency injection mechanisms, in particular where you had the add context, DI from Jakarta REST, and CDI. If you had if you were working in an environment where both were available, there were some problems with constructors, because essentially when the bean is constructed, it has to be in charge of one DI and not the other. And when you try to mix and match, then you run into problems. So by moving to CDI, we're going to have more options, and we're going to be able to inject different types of beans in the constructor, which was difficult to do before. So the right-hand side has an example where we're injecting a regular bean, which is a greet bean, CDI bean, as well as a query parameter, or all in the same constructor. All right, so to recap, field injection doesn't really change much. We may have to add inject in some places where we didn't use it before. And it's going to give us a few more options when it comes to constructors, and remove some of the confusion about constructing beans when multiple dependency injection mechanisms are in place. What about, okay, so let's just to recap the example, add inject on the constructor, the ability to do param injection as well. One of the little problems is that CDI supports essentially a single constructor, at least up to this point. Jakarta REST decided to support multiple constructors and way back when, and it would pick the one with the largest number of parameters that it can supply. So this would be sort of a shortcoming, but for the most part, it's really not a problem. You can do field injection, and you can do other things to get around this. The one thing that could be a problem is the default constructors for proxying, and I'll come back to this one later, but this is something that CDI requires. So what about the rest of the resource class, resource methods in particular. Well, some of them are not going to change at all. So on the left-hand side at the top, we have one resource, a very simple one, get message, and that's exactly the same as how it would look like in 4. Now, most of the changes are going to be around the way we process or we define the parameters for the resource method. On the left-hand side, on the second one, we have, for example, string message. This is what we call the entity. And the reason we know it's an entity because it's the parameter that has no Jakarta REST annotations. So you could have other annotations, such as validation annotations, but if it has no Jakarta REST annotations, then we know it's the entity. Because we want to make this a bit more flexible, and we want to have the ability to inject arbitrary beans, as we'll see in other examples as well. It's probably better if we switch to, again, an incompatible change where the entity is explicitly marked as so. So it would be a new annotation called add entity. But the advantage of that is that we can then eliminate the need for any annotations on pretty much anything else that we want to inject, because we no longer have this restriction that we had before. So things like async response. So this will be an example of an async resource. We use the @suspended annotation. It's not really required anymore. If we go in this direction, we can just detect that we're injecting a bean that is controlled by Jakarta REST rather than the application. And of course, it has a special meaning for the specification and can be injected as such. Okay, so let's recap resource method injection. So one of the things that we don't need to do is annotate the method with @inject, and the reason for that, at least not up to this point, is because the call will be all controlled by the Jakarta REST implementation. So we know what we're doing, and we know we need to do injection. And so it only adds verbosity at this point. We would allow injection of arbitrary CDI beans, and I have an example for that. We would probably require, and this is all up for discussion, but it's the idea of presenting a preview. We will probably have a new annotation to denote the entity and remove other annotations where they are not really required. So let's take a look at another example, probably a more interesting one. As many of you know, we have support for server-sent events. So you can have resources that handle events, send events to clients. And so we have special types in the API for that, things like SSE and SSE event sync. And the way you would normally inject these, you can either do it as a parameter, or you can do it as a field injection, but most of the time people use these as parameters. And you can inject them using @context, because that's the injection mechanism that we have. Well, if we have the @entity and we move to this world where everything else that we inject is a bean, then again, these just becomes beans that are provided by the Jakarta REST implementation. So we don't have to do that anymore. So in some sense, in a few cases, you're going to have to write a little bit more. In other cases, this is going to probably simplify the implementation and eliminate some annotations. Okay, so the other thing I talked about is bean discovery and scopes. So scopes, I think for the most part, is pretty straightforward. There are some edge cases, as usually we have. But talking about bean discovery, there's a few things that we can do to make this a little bit easier. One of the things that we could do is we could make things like @path, @provider, and @application path as bean defining annotations in CDI. And when you do that, then you automatically get information about those beans as they become, as they are getting discovered at runtime. And the advantage, of course, is that we don't need to add any other annotation to say, hey, these are going to be part of my application. And this connects to another slide about what we're going to do with the application subclass, or what we could do with the application subclass. Resources in request scope, we already talked about that. Providers in application scope, and of course these are the defaults. Just like if you use a Jakarta REST application today in a CDI environment, you can change the scope of the beans as you like. But by default, this is what we're going to do. And then for the application subclasses, there's a bit of an exception here, because one of the things that we could potentially do is support the ability to have more than one application subclass. And I'll wait on that discussion for a bit. And then default scopes can be overridden, as I've already said. All right, let's talk about the application subclasses. So one of the things that we can do with discovery is not force the developers to provide any application whatsoever. And this is something that is already done in some newer frameworks these days. Essentially, what you do is you just look around and see what are the resources and what are the providers that are available. And assuming that you have discovery enabled, you can collect all these together and sort of create a synthetic subclass without the developer having to specify that. Of course, that's not going to apply to all the services, but it's going to apply to a lot of them. So the CDI bean discovery mechanism is useful in the same way we use the equivalent servlet one when we were running in those environments. Now, the other thing that we could do, and this is something that, again, some frameworks do support already, is the ability to have more than one, or more than two, I should say, more than one, two or more application subclasses. And the use case for this is that sometimes you have a service that you want certain resources to be publicly available and others to be protected in some way, some form of authentication authorization. Now, there are some security libraries built on top of Jakarta REST, and many of those use annotations. And so the natural place for those annotations to live is associated with application subclasses. Well, you could put them in other places, but this would be one place where you could put them. And so you could define a different security mechanism for one application subclass for those resources that are public versus those that are private. And so an easy way to do that is to have multiple application subclasses that can basically split the resources and maybe even the providers that your service has available. And now the problem with this is that it introduces some issues with scopes, because today you can actually, in fact, inject the application subclass, and the application subclass that you have, it's going to be obviously an application scope. But if you have more than one, then this becomes a bit of a problem. You would probably want to inject the one that is specific to the request that is being processed, which would make that application subclass in request scope rather than application scope. So the ability to have more than one application subclass opens the door for some new use cases to be easily supported, but at the same time, it brings some problems that we will need to solve. So this is still another discussion that we need to have. All right, so I guess this is going to be a rather short presentation today, but there's a lot of open questions. I've only scratching the surface here of the number of things that we're going to have to look at. Number one is the implication of CDI Light. Some of you may know that CDI Light is something that the CDI group is working on. And the idea here is that, to me, the best way to describe it is to think about the open world versus closed world assumption. And this is why it connects to native compilation, if you're interested in such a thing. So CDI has been very dynamic up to this point. So this is why you have all these portable extensions that do all sort of magic when they start. And many frameworks rely on that very heavily. Now, in environments such as application servers or servlet containers, the ability to discover everything that was available at runtime was very useful. That's arguably a little bit less useful when you're writing microservices. Usually in a microservice, whatever you know at compile time is whatever you have at runtime. You're not going to discover a lot of newer things. And this is why there are many frameworks these days that support the idea of doing the scanning and the discovery of everything that is out there at compile time rather than at runtime. And of course, the motivation for that is that you want the startup time to be as fast as possible. And the more you can do at compile time, the faster your runtime is going to be. This makes a lot of sense for certain cloud applications. Cloud Functions is an example of that, where you want the startup to be as quick as possible, and you don't want to be discovering the world at that time. So CDI Lite is something very interesting. I think that it's going to be very useful for Jakarta REST. It's unclear at this time whether Jakarta REST will need to do anything special about it, whether it needs to support a special light mode, but it's certainly something we need to look at, especially if we're going to be fully dependent on CDI as 4.0 intends to be. The other thing that we need to do is support or look at possibly supporting reactive streams. Reactive streams obviously connect very nicely with servers and events. Essentially, what you're doing on the server side is you're providing a publisher that is going to publish events for the client to consume. So the equivalent would be the subscriber on the client side that would look at those events and process them. And the advantage of this is that there are a lot of libraries out there, as many of you know, that can do things with the reactive streams. So it connects really nicely with other things like messaging and other things. And then lastly, the CDI mandates a no R constructor for proxying, and this applies to not all the scopes, but most of the interesting ones, so-called normal scopes. So if you're using a dependent scope, then this is not a problem. But anytime you have to do proxying, which of course we would need to do, or CDI would need to do for us in Jakarta REST, there is this mandate of a no R constructor. Now, implementations have worked around this. Weld has a way to get around this. I believe they're using some internal JDK calls in order to do this. But this is something that we need to understand a little bit better, because it's not something that we had before. Or sort of we did, but only in the case where we were integrating with CDI, not in normal JAX RS. So with that, I think we're going to be ready for some questions.
Okay, let me check the chat here.
All right, I see Arjun has something about executing business methods and mining parameters. So it looks like some work is going on there. This is one of the things that I mentioned that could be useful for us to implement resource methods. So definitely something we need to look at. Okay, so I'm looking for questions. Somebody happy about Multipart? Yeah, it was, yeah.
I just see one question down here. So how to get some different file in REST API. I don't know if that's a question or more of a comment.
Yeah, I'm not really sure what it means to have. Okay, Daniel and SSE API reactive, yeah, sure. The person that asked about the different file in REST API, could you possibly elaborate on that? If you're still here.
All right, while we wait for that, I'll just like to thank you, Santiago, for that presentation today. And just a reminder to everyone in the audience, if you have any final questions, please feel free to put them in the chat or using the Ask a Questions tab. I'll give you a few minutes to do that while I just wrap up here. So the next Jakarta Tech Talk is September 15th with Michael Redlick, as he joins us to present Getting Started with Jakarta, NoSQL, and MongoDB. And you can register for that using the link I just put in the chat. We're also looking to book more Jakarta Tech Talks. So if you're interested in presenting your own talk, we would more than happy to have you. So I'll put that link as well. And then if you have any other questions for Santiago after today, I have his contact information here. So you can reach out to him and ask him any questions. Let's see if we have any clarification on that. Okay, so we have another question here. So what's expected release of Jakarta 11?
Yeah, that's really a question that goes way beyond this presentation, but I would say sometime next year. 10 is going to, I think the current date is sometime in late October. So I don't really have a more specific date at this time. Okay. So Arjun has a question about servlets or two. Okay, so about having a better integration with Servlet, I believe is the question, or Servlet Lite, which honestly I'm not that familiar with, but yeah, definitely something we can look at. I will definitely put it as something to look at for. Maybe I don't know if Arjun, you can share more information about Servlet Lite and what's not in it, or maybe a link to it.
All right. And if anyone else has any other questions, you can just pop them in the chat now as we wrap up. Oh, there's Arjun.
Okay, so he's in plan not there. Okay. All right. Yeah, we'll definitely have time to look at that. Okay. All right. I think we could probably wrap it up here.
Perfect. So it doesn't look like there's any other questions. So I'd just like to thank you again, Santiago, for that presentation, and thank you all for attending. I hope you all enjoy the rest of your day.
All right. Bye-bye. Thank you, guys.
Bye. Thanks.